Hello friends, welcome to Learner's Planet. Friends, this is our fifth session for polynomials. In the last session, we have discussed factor and remainder theorem. We have also done some examples and problems based on factor and remainder theorem. In this session, we will be continuing with the factor and remainder theorem, and we'll be taking some problems and applications of factor and remainder theorem. So let's begin this session. First of all, let's have a quick recap of remainder theorem. Okay, now what remainder theorem is? If a polynomial px is divided by x minus a, the remainder is pa. The polynomial px is divided by x minus a, then the remainder is pa. Remainder theorem. If polynomial px is divided by x minus a, then the remainder is pa. Now this theorem we will be using to solve the given problems. Okay, now let's take the first problem. Here in each of the following we have to use remainder theorem, and we have to find out the remainder when fx is divided by gx. Okay, now according to the theorem, if fx is divided by gx, that means x minus 1, then the remainder should be pa. So first of all, let's calculate the value of a. It is x minus 1. If I compare it with x minus a will be 1. Okay, and there are two methods, and in the previous session we have already discussed the other method. You just equate x minus 1 to 0. So whatever the value of x you are getting is the value of a. Okay, so we have to calculate fa, that is f1. So fa is equal to f1, that is, just put the value of x as 1, 4 minus 3 minus 2 plus 1 minus 7. So 4 minus 3, 1, 1 minus 2, minus 1, minus 1 plus 1, 0. Finally, we are getting minus 7. So when x minus 1 is divided by, if fx is divided by x minus 1, the remainder will be minus 7. And that remainder we are calculating not by performing the actual division, but by the using remainder theorem. Okay, so I hope you are clear. Let's take the next example. Now in this question, f of x is x cube plus 4x square minus 3x plus 10, and g of x is x plus 4. Now we have to find the remainder when fx is divided by gx. So further we'll be using remainder theorem, and we'll be calculating the value of a. So let's compare x plus 4 to x minus a. So we'll be getting a is equal to minus 4, or alternatively put x plus 4 is 0. So x is equal to minus 4, which will be the value of a. Okay, now what we have to calculate? We have to calculate fa, that is f of minus 4. So put the value of x as minus 4 in this expression. So it's minus 4 cube plus 4 into minus 4 square minus 3 into minus 4 plus 10. So it's minus 64. Minus 4 square is 16, and 16 into 4 positive 64 plus 12 plus 10. So it's 22. So if x cube plus 4x square minus 3x plus 10 is divided by x plus 4, we will be getting the remainder as 22. Okay, now let's take the next problem. Friends, we have done so many questions. Now I would recommend you to just have a paper and pen with you. You just pause the session, solve the problem on your own, then see my solution and match your answer. Okay, now let's take this problem. It's f of x is 2x4 plus 6x cube plus 2x squared minus x plus 2, and we have to find the remainder when fx is divided by gx. Further, we will be using remainder theorem. Let's get the value of a. It's x minus a, that means a is equal to minus 2, or we can say x plus 2 is 0, that means x is equal to minus 2, or we can say it is a. So what we have to calculate? We have to calculate fa, or I can say f of minus 2. Okay, so just put the value of x as minus 2 in this expression. So it will be 2 into minus 2 raised to 4 plus 6 into minus 2 cube plus 2 into minus 2 square minus of minus 2 plus 2. So that is minus 2 raised to 4 will be 16. 16 2s are 32. Minus 2 cube will be minus 8. Minus 8 into 6 is minus 48. Then it's 4 2s are 8. Then it's plus 2 and it is plus 2. So 32 plus 8 40. 40 plus 4 44. 44 minus 48 is minus 4. That means if we divide this expression by this, we will be getting the remainder as minus 4. Okay, I hope you are clear and your solution is matching with mine. Let's take the next example. In this question, this is fx, gx is x plus half. So let's find out the value of a. It's x minus a, that means a is minus half. So we have to calculate f of a, that is f of minus half. Now put the value of x as minus half in this expression. So what we will be getting? It's 4 into minus half cube minus 12 minus half square plus 11 into minus half minus 3. So it's minus of 4 into 1 by 8. Then it is minus 12 by 4. Then it is minus 11 by 2. And it is minus 3. Okay. So what we are getting, it's minus half minus 3 minus 11 by 2 and minus 3. So we can solve it. It's 11 plus 1, that is 12 by 2 6 and 6 12. So we'll be getting minus 12. Okay, so if we divide this expression by this expression, we will be getting the remainder as minus 12. Isn't it so easy? Let's take one more example. Now let's say this question. 9x cubed minus 3x square plus x minus 5 is divided by 3x minus 2, and we have to find out the remainder. Okay, now let's get the value of a. 3x minus 2 is 0. That means x is equal to 2 by 3, which is a. So now we have to calculate fa, which will be f of 2 by 3. So put the value of x as 2 by 3 in this expression. So it is 9 into 2 by 3 cube minus 3 into 2 by 3 square plus 2 by 3 minus 5. So it's 9 into 8 by 27 minus 3 into 4 by 9 plus 2 by 3 minus 5. Okay. So in the next step, it's 9 threes are, it's 3 threes are, it's 8 by 3 minus 4 by 3 plus 2 by 3 minus 5. So what we can do is, we can write it as 15 by 3. Now 8, I just write it over here, 8 minus 4 plus 2 minus 15 by 3. So 8 plus 2, 10, minus 19 by 3. So it's minus 9 by 3, which is minus 3. That means if this expression is divided by this expression, we will be getting the remainder as minus 3. Okay, very simple. Let's take one more problem. Now in this question, first of all, let's calculate the value of a. So it is 1 minus 3x is 0. That means 3x is equal to 1. That means x is equal to 1 by 3, which is value of a. Okay, so now we have to calculate fa. That is f of 1 by 3. So let's put the value of x as 1 by 3 in this expression. So it's 1 by 3 cube minus 6 into 1 by 3 square plus 2 into 1 by 3 minus 4. So it's 1 by 27 minus 6 by 9 plus 2 by 3 minus 4 by 1. Now let's take LCM. It's 1 minus 9 threes are and 3 6 are 18 plus 3 9 and 9 2s are 18 minus 1 into 27, that is 27, and 27 into 4 is 108. So what we are getting is minus 107 by 27. So if this expression is divided by this expression, we will be getting the remainder as minus of 107 by 27. Okay, so I hope you are clear how to find out the remainder when one expression or a polynomial is divided by the other. Okay. Now let's try some word problems based on remainder theorem. Let's see the first question. If the polynomials this and this leave the same remainder when divided by x minus 2, find the value of a. A very simple application of remainder theorem. Since we are already clear with the remainder theorem, I'll be solving the problem directly. Now I assume this polynomial to be fx. So let's write it over here. Fx is 2x cube plus ax square plus 3x minus 5, and this polynomial to be px. So it's x cube plus x square minus 4x plus a. Now this is gx. Gx is x minus 2. Okay. Now I have to divide fx and px by gx and find out the remainder. So let's equate gx to the 0. So x is equal to 2. That means we have to calculate f2 and p2. So what f2 is, put the value of x as 2. So 2 into 2 cube plus a into 2 square plus 3 into 2 minus 5. So it's 2 cube is 8. 8 into 2, 16 plus 4a plus 6 minus 5. Or we can say 16 plus 6, 22. 22 minus 5 is 17. So when fx is divided by gx, the remainder is 4a plus 17. Similarly, we calculate p2. That is 2 cube plus 2 square minus 4 into 2 plus a. So it's 8 plus 4 minus 8 plus a. So it's a plus 4. Now according to the question, these two remainders are same. So let's equate them. So 4a plus 17 is equal to a plus 4. That means 3a is equal to 4 minus 17, that is minus 13. So a will be minus 13 by 3. Okay, it's very simple to calculate the value of a in this case. Let's do one more problem. Now similar question. If the polynomial ax cube plus 3x square minus 13 and 2x cube minus 5x plus a when divided by x minus 2 leave the same remainder, we have to find out the value of a. Friends, just pause the session, try the problem on your own and then match your solution and answer with mine. Okay, I assume this polynomial as fx. So I write fx over here. It is ax cube plus 3x square minus 13. I assume this to be px. So I write px over here. It's 2x cube minus 5x plus a. Okay. And this is x minus 2. Okay. So we have to find out the remainder. So we have to gx is x minus 2, which is 0. That means x is equal to 2. So what we have to calculate is f of 2. So f of 2 is a into 2 cube plus 3 into 2 square minus 13. So it's 8a plus 4 3s are 12 minus 13, or it is 8a minus 1. Okay, now similarly, if px is divided by gx, we have to find out the remainder. So let's calculate p2. It's 2 into 2 cube minus 5 into 2 plus a. So it's 8 2s are 16 minus 10 plus a. So it's a plus 6. Now further, according to the question, this remainder and this remainder are same. So let's equate them. 8a minus 1 is a plus 6. That means 7a is equal to 7. That means a is equal to 1. Okay, very simple. Now let's see this question. Find the value of k if the division of this expression by x plus 3 leaves a remainder minus 22. Now further we are going to apply remainder theorem. We are going to divide this expression by this expression. Okay, so let's assume this to be fx. So fx is kx cube plus 9x square plus 4x minus 10, and this is gx. It is x plus 3. Now equate gx to 0. So x plus 3 is 0. That means x is equal to minus 3. Now we have to calculate f of minus 3. So put the value of x as minus 3 in this expression. So it's k into minus 3 cube plus 9 into minus 3 square plus 4 into minus 3 minus 10. Okay, so it's minus 27k. It's 9 into 9, 81, minus 12 and minus 10. Finally, we are getting minus 27k plus 59. Now, if we divide fx by gx, we are getting the remainder as minus 27k plus 59. But in the question, it says that the remainder is minus 22. That means this expression or this remainder is nothing but it is minus 22. Okay, so we can equate both of them since both of them are same. So minus 27k plus 59 should be minus 22. So minus 27k should be minus 22 minus 59. So we can get the value of k, which is 81 by 27, that is 3. Okay, a very simple application of remainder theorem. Okay, let's do more questions. Now let's try this question. The polynomial px when divided by x plus 4 leaves a remainder minus 28. We have to find out the value of k. So let's see how does it happen. Px is equal to kx cube plus 15x square plus 9x minus 40. And let's suppose x plus 4 as gx. Now gx is x plus 4 and we have to equate x plus 4 to 0. That means x is equal to minus 4. So what we have to calculate is, we have to calculate f of minus 4. Now put the value of x as minus 4 in this expression. So it's k into minus 4 cube plus 15 into minus 4 square plus 9 into minus 4 minus 40. So it's minus 64k, 15 into 16 240. It's minus 36 minus 40. So finally we are getting minus 64k plus 164. Okay, now if fx is divided by, the px is divided by gx, the remainder is minus 64k plus 164. But in the question, we are given this remainder as minus 28. That means minus 28 is this. So we can equate them. Okay, so minus 64k plus 164 is minus 28, or we can say 64k is equal to 164 plus 28. So it's 192. That means k is equal to 192 by 64, that is 3. Isn't it so simple? Okay, let's do more problems. Now let's see this interesting question. If x cube plus px square plus qx plus 6 leave remainder 3 when divided by x minus 3 and leaves 0 when divided by x minus 2, then we have to find out the value of p and q. Suppose this is fx. So fx is equal to x cube plus px square plus qx plus 6. And let's suppose x minus 3 as gx. So gx is x minus 3 and this is hx. So hx is x minus 2. Now we have to find out the remainder when fx is divided by gx and fx is divided by hx. So first of all, let's divide fx by gx. We will be using remainder theorem to find out the remainder in this case. So first of all, equate gx, that is x minus 3, to 0 and get the value of x. Now we have to calculate f3. And what f3 will be? F3 will be remainder when fx is divided by gx. So let's put the value of x as 3 in this equation. So 3 cube, that is 27, plus 3 square p, that is 9p, plus 3q plus 6. So 9p plus 3q plus 33. Okay. Similarly, when this expression, that means fx is divided by hx, the remainder is 0. So let's divide it. x minus 2 is 0. That means x is equal to 2. So now we have to calculate f2. Now put the value of x as 2 in this expression. So it's 8 plus 2 2s are 4p plus 2q plus 6. So 4p plus 2q plus 14, and this is given as 0. Since fx is divided by hx, the remainder is 0. That means it is 0. Or we can say 2p plus q is equal to minus 7. In this expression, when fx is divided by gx, the remainder was 3. So this is actually 3. That means 9p plus 3q is minus 30. Or we can divide this expression by 3. So it's 3p plus q is minus 10. Okay. Now we have to solve this pair of equation, and we have to get the value of p and q both as well. Okay. Let's see how do we calculate it. Now here 2p plus q is minus 7 and 3p plus q is equal to minus 10. So we can calculate the value of q from this expression and put the same value of q in this expression. Okay. So q is equal to minus 7 minus 2p from first, and we'll be putting the value of q in the second equation. So it's 3p minus 7 minus 2p is equal to minus 10. So 3p minus 2p is p is equal to minus 10 plus 7. So p is equal to minus 3. Now we can put the value of p as minus 3 in this equation, and we can get the value of q. So q will be minus 7 and p is minus 3. So minus 2 into minus 3 is plus 6. So it's minus 1. So the value of p is minus 3 and the value of q is minus 1. Quite interesting and simple problem it was. Friends, we'll be solving more such problems in our next session. Till then, do revise this session and the previous session of factor and remainder theorem. Bye-bye.